malas.
Kita rajin kot.
Rajin apa tidur.
Masanya.
untuk sekawan, gadis jelita, buat santapan jangan ketawa ni. Buat santapan untuk pahlawan. Tampillah tuan, kami meminta memadah ucapan, kata aluan. Para hadirin yang dihormati sekalian, majlis menjemput dan mempersilakan yang berusaha Profesor Madya Dr. Muhammad Faizal Nizam bin Abdullah. Okey, tak boleh itu takut. Kontrol. Dalam 2 minit start tu. Dalam 2 minit rasanya. Rotasi selepas ke pelatas ke ni? Sebelum Prof. Kan? Sebelum Profesor. Nama dia ni? Profesor Dr. Khalid bin Saliman. TNC ke VC? Oh VC lagi gila. Profesor Datuk. So yang ni first tau. Sini. Tulis kat sini. Mana? Tadi kan aku tulis kat laptop. Aku pindah kat sini. Kat sini ya? Dotok.
Itu ni salutation lah. Prof dia ada salutation dia sendiri. Tapi tak apalah.
Okey. Datuk ke Prof lu Datuk kan?
Prof Datuk.
Profesor Datuk Dr. Amin bin Maktar. Head Chancellor Universiti Pendidikan Sultan Idris.
Dia hadir secara atas talian.
Dia ada gigil.
Tengok dalam 5,000 je.
Kenapa tak 10,000 kak? Timbalan Vice Chancellor kau tak Naib Chancellor Universiti Pendidikan Sultan Idris yang bersama dengan kita secara atas talian. Secara atas talian.
Boleh tak tambahkan dekat ni tau?
Kenapa? Memang untuk menyambut.
Gitu, tak boleh baca dah. Aku tulis rasis. Korang ni kan tak sempat, tak boleh nak baca.
Yang apa kak?
Atas Profesor ni tulis kali yang dapat.
Apa VC lu kan VC. Baru Profesor kan?
Betul.
Okey.
Tadi ayat ni kat situ. Ayat
yang bersama dengan kita secara atas talian.
Yang bahagia.
Yang dia orang confuse, dia orang akan sebut yang itu terus, tak ada ke tak apa?
Tak apa. Okey.
Dia tadi yang berusaha ke yang berbahagia?
DC kan? DC seorang je yang bahagia. Angkut dia berusaha.
TNC Profesor Suriani pun sama juga kan?
Yang berusaha. Yang akak belajar ke yang Aiman
tak, saya tak tahu. Kalau saya ikut yang ni, kalau Profesor ni saya guna yang kat sini, saya guna yang berbahagia. So macam mana? Sebab yang diraikan kan? Yang diraikan
boleh.
So yang lain yang berusaha je lah. MAD kan? Kalau lepas selesai ni, saya dah boleh baca kan?
Boleh.
Mataf. Yang sudah ada bersama dengan kita secara atas talian. Ya Allah. Tak nampak pulpen ni.
Ni pula tak ada.
Betul tu. Ya. berlaku je. Ya Allah, buruknya tulisan aku.
Ya. Dah boleh baca kan? Boleh tu. Tak apa, aku start je. Dia lupa, rasa boleh start ni. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Mohon perhatian bagi memastikan majlis kita berjalan dengan lancar. Para hadirin diingatkan agar mematikan atau memastikan telefon bimbit anda berada dalam pengatur caran senyap. Majlis turut ingin mengingatkan supaya semua hadirin mematuhi SOP yang telah ditetapkan. Dimohon semua hadirin untuk kekal memakai pelitup muka, menjaga jarak dan sentiasa menggunakan hand sanitizer. Apabila diumumkan ketibaan yang berbahagia, Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Naib Chancellor Penyelidikan Inovasi UPSI, diiringi div-div kehormat dan tetamu jemputan. Hadirin dimohon untuk berdiri. Kerjasama hadirin amat dihargai dan didahului dengan ucapan terima kasih. Mengumumkan ketibaan yang berbahagia, Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Naib Chancellor Penyelidikan Inovasi UPSI, diiringi div-div jemputan masuk ke perkarangan majlis. Hadirin diminta untuk terus berdiri bagi menyanyikan lagu Negaraku dan Ibu Kandung Sulu Budiman.
Bersama kandung suluh budiman, oh budiman alam gelap, bina budi penyebar tekad, pancaran semangat wajah. Ibu kandung suluh budiman, ibu pujaan kami, yang berjasa pada masyarakat, hidup gagah berani. Ibu kandung suluh budiman, denganlah sumpah sumbang sinar suci, selagi hayat di kandung badan, kami tetap berbakti. Selagi hayat di kandung badan, kami tetap berbakti.
Hadirin dipersilakan duduk. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Sayang kumbang mencari makan, terbang seiring di tepi kali. Selamat datang kami ucapkan, moga diiringi restu ilahi. Bismillahirrahmanirrahim. Yang berbahagia, Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Naib Chancellor Penyelidikan dan Inovasi, Universiti Pendidikan Sultan Idris. Yang berusaha, Profesor Datuk Dr. Mat Amin bin Maktaf, Naib Chancellor Universiti Pendidikan Sultan Idris yang turut bersama dengan kita pada hari ini secara atas talian. Yang berusaha, Profesor Madya Dr. Muhammad Faizal Nizamli, Dekan Fakulti Sains dan Matematik. Yang berusaha, Profesor Dr. Ismail Zainul, Profesor Fakulti Sains dan Matematik. Yang berusaha, Profesor Madya Dr. Nurjan Yusof, Pengarah Pusat Pengurusan Penyelidikan dan Inovasi. Yang berusaha, Profesor Madya Dr. Azmi Muhammad, Pengarah Bahagian Perancangan Korporat. Yang berusaha, Profesor Madya Dr. Ahmad Jazimin Juso, Timbalan Pengarah Pusat Pengurusan Penyelidikan dan Inovasi. Ketua-ketua Pusat Tanggungjawab Kaki Tangan Universiti Pendidikan Sultan Idris, tetamu jemputan yang bersama-sama di atas talian dan hadirin dan hadirat yang berada di Dewan Konvensyen E-Learning UPSI. Majlis mengalu-alukan dan mengucapkan jutaan terima kasih atas kehadiran semua.
Kalau pergi ke Tanjung Keramat, anak manis jangan diangkat. Bersama kita memohon rahmat, moga majlis mendapat berkat. Majlis mempersilakan Saudara Ustaz Azizi bin Muhammad Hussein daripada Pusat Islam UPSI untuk memimpin bacaan doa. Dipersilakan.
Al-Fatihah. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Allahumma yassir wa la tu'assir fa inna taysiraka 'alaika yasir. Allahumma la yahtaju ila al-bayani wa tafsir, hajatuna katsir wa anta 'alimun wa khabir. Ya Allah, ya Tuhan kami, dengan sifat-sifat keagungan-Mu serta kebesaran-Mu, bersempena dengan program syarahan Perdana Pelantikan Profesor Dr. Suriani binti Abu Bakar pada hari ini, kami sekalian hamba-Mu merafak tangan dengan penuh kerendahan hati agar Engkau curahkan nikmat yang berterusan kepada kami. Engkau kurniakanlah petunjuk kepada kami bagi mencapai keredaan-Mu. Engkau jauhkanlah kami dari segala musibah dan mara bahaya, serta ampunilah dosa-dosa kesalahan yang kami lakukan, sama ada yang tersembunyi maupun yang nyata. Ya Allah, dengan sifat kasih sayang-Mu, bersempena dengan program bermanfaat ini, tanamkanlah sifat-sifat terpuji dalam diri kami agar terbina kecintaan kami kepada ilmu dan budaya kerja yang berkualiti menjadi amalan kami. supaya dengan itu kami sentiasa berusaha melakukan penambahbaikan demi kebaikan dunia dan akhirat. Allahumma ja'al jam'ana hadza jam'an marhuma wa tafarruqana min ba'dihi tafarruqan ma'suma. Ya Allah, jadikanlah perhimpunan pada hari ini satu perhimpunan yang dirahmati dan perpisahannya nanti perpisahan yang dipelihara. Rabbana atina fid dunya hasanah wa fil akhirati hasanatan wa qina azaban nar. Wa sallallahu ala sayyidina Muhammadin wa ala alihi wa sahbihi wa sallam. Walhamdulillahi rabbil alamin.
Amin, amin ya rabbal alamin. Terima kasih diucapkan kepada Ustaz Azizi bin Muhammad Husni daripada Pusat Islam UPSI atas bacaan doa sebentar tadi. Semoga majlis kita pada pagi ini diberikan keberkatan dan keredaan oleh Allah Subhanahu Wa Taala. Sidang hadirin sekalian, buat pengetahuan semua, majlis yang penuh bermakna pada pagi ini merupakan majlis syarahan Perdana Pelantikan Profesor anjuran bersama Pejabat Timbalan Naib Chancellor Penyelidikan dan Inovasi dan Fakulti Sains dan Matematik UPSI. Syarahan ini akan diberikan oleh Yang Berbahagia Profesor Teknologis Dr. Suriani binti Abu Bakar yang merupakan Timbalan Naib Chancellor Penyelidikan dan Inovasi Universiti Pendidikan Sultan Idris. Duduk sekawan gadis jelita, buat santapan untuk pahlawan. Tampilah tuan kami meminta, memadah ucapan kata aluan. Para hadirin yang dihormati sekalian, majlis menjemput dan mempersilakan yang berusaha Profesor Madya Dr. Muhammad Faizal Nizamli Abdullah, Dekan Fakulti Sains dan Matematik UPSI untuk memberikan ucapan alu-aluan beliau. Dengan ini, majlis mempersilakan.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Terima kasih kepada pengurusi majlis. Yang berusaha Profesor Datuk Dr. Muhammad Amin Maktaf, Naib Chancellor Universiti Pendidikan Sultan Idris yang juga hadir dalam talian. Yang berusaha Profesor Dr. Suriani Abu Bakar, Timbalan Naib Chancellor Pendidikan dan Inovasi yang juga merupakan profesor di Fakulti Sains dan Matematik Universiti Pendidikan Sultan Idris. Yang berusaha Profesor Dr. Ismail Zainal, profesor di Fakulti Sains dan Matematik. Yang berusaha Profesor Maya Dr. Nurjan Yusof, pengarah Pusat Pengurusan Pendidikan dan Inovasi. Yang berusaha Profesor Maya Dr. Azmi Muhammad, pengarah bahagian perancangan korporat. Yang berusaha Profesor Maya Dr. Ahmad Jazimin Yusof, Timbalan Pengarah Pusat Pengurusan Pendidikan dan Inovasi, Ketua-Ketua Pusat Tanggungjawab, Kaki Tangan Universiti Pendidikan Sultan Idris, tetamu jemputan yang bersama-sama di atas talian dan hadirin hadirat yang berada di Dewan Konvensyen E-Learning UPSI. Alhamdulillah. Syukur kita kehadrat Allah Subhanahu Wa Taala kerana dengan limpah kurnianya dapat kita meluangkan masa menghadiri majlis syarahan perdana pada pagi ini yang akan disampaikan oleh Yang Berusaha Profesor Teknologi Spesialis Dr. Suriani Abu Bakar. Saya mengucapkan jutaan terima kasih kepada semua tetamu jemputan yang sudi hadir di Dewan Konvensyen E-Learning ini dan juga secara maya di platform Facebook Live Universiti Pendidikan Sultan Idris dan pejabat TNCPI. Seterusnya, izinkan saya memperkenalkan seberingkas Profesor Teknologi Spesialis Dr. Suriani Abu Bakar sebagai ahli akademik Fakulti Sains dan Matematik Universiti Pendidikan Sultan Idris. Setelah tamat kursus sarjana, Profesor Dr. Suriani telah ditawarkan jawatan sebagai pensyarah di UPSI pada tahun 2006 yang sebelumnya menjawat jawatan tutor. Karier sebagai pensyarah bermula dengan melakukan pelbagai tugasan seperti pengajaran, penyelidikan, penerbitan dan lain-lain. Pada tahun 2008, Profesor Dr. Suriani telah dihantar melanjutkan pengajian di peringkat Doktor Falsafah di Universiti Teknologi Mara dengan program sangkutan di Nagoya Institute of Technology, Japan. Sewaktu menjalani pengajian PhD ini, Profesor Dr. Suriani menjalinkan kolaborasi bersama ramai penyelidik yang hebat. Antara penemuan hebat beliau adalah vertically aligned carbon nanotube dan dari minyak kelapa sawit yang kemudiannya telah diterbitkan dalam jurnal Q1 Elsevier. Untuk pengetahuan semua, penemuan ini adalah yang pertama seumpamanya dari Malaysia. Penemuan ini kemudiannya telah membuka pelbagai peluang lain dan melonjak nama beliau dalam bidang fizik nano, teknologi nano dan elektronik nano. Bidang kepakaran dan penyelidikan Profesor Dr. Suriani tertumpu kepada penghasilan bahan nano berasaskan karbon seperti graphene dan aplikasinya dalam peranti elektronik. Melalui penyelidikan yang dihasilkan, beliau telah menerbitkan lebih daripada 211 artikel berindeks Scopus dengan H-index Scopus melebihi 24. Citasi melebihi 1,874 dan faktor impak kumulatif bagi semua penerbitan melebihi 200. Melalui penyelidikan berasaskan bahan termaju dan nanoteknologi, Profesor Dr. Suriani Abu Bakar telah berjaya memenangi beberapa anugerah penyelidikan yang sekaligus telah berjaya melonjakkan nama Fakulti Sains dan Matematik dan Universiti Pendidikan Sultan Idris. Antara anugerah yang berjaya dimenangi oleh Profesor Dr. Suriani ialah anugerah L'Oreal UNESCO for Women in Science National Fellowship 2013. Beliau juga menerima anugerah Young Researcher Award in Solid State Science and Technology 2016 dari Malaysian Solid State Science and Technology Society dan mewakili Malaysia dalam The Asian US Science Prize for Women 2019. Kemahiran kepimpinan beliau juga telah terselah apabila beliau dilantik sebagai Ketua Jabatan Fizik di Fakulti Sains dan Matematik UPSI dan telah membantu fakulti dalam pembinaan program-program akademik baharu di fakulti. Seterusnya, beliau terus mengorak langkah menyumbang kepakaran kepada UPSI apabila dilantik sebagai pengarah di Pejabat Karang Mengarang. Pihak universiti juga telah memberi kepercayaan kepada beliau sebagai Ketua Editor bagi Jurnal Educatum Science, Matematik dan Teknologi. Dan kini beliau berkhidmat sebagai Timbalan Naib Chancellor Penyelidikan dan Inovasi dengan agenda membawa UPSI cemerlang dan gemilang dalam 5P yang meliputi penyelidikan, penerbitan, perundingan, pengkomersialan dan penarafan. Selain itu, beliau turut diberi kepercayaan oleh pihak Kementerian Pengajian Tinggi untuk mengetuai program Festival of Ideas dan beberapa program di peringkat nasional. Di peringkat antarabangsa pula, beliau turut dilantik sebagai pengerusi jawatan kuasa penyelidikan bagi KPU, the Consortium of Asia Pacific Education Universities. Kami bagi pihak fakulti dan warga UPSI amat berbangga dengan pencapaian cemerlang serta kepimpinan melalui teladan yang telah ditunjukkan oleh Profesor Dr. Suriani Abu Bakar. Diharapkan dengan semangat dan komitmen beliau dalam pengembangan ilmu sains dan teknologi melalui penyelidikan mampu mengetengahkan penyelidikan yang dapat membawa manfaat kepada warga UPSI, komuniti setempat dan negara. Diharap Profesor Dr. Suriani dapat terus membawa nama universiti ke peringkat lebih tinggi dengan pelbagai pencapaian di peringkat kebangsaan dan antarabangsa. Sekian, wabillahi taufik wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Dan terima kasih.
Terima kasih diucapkan kepada Yang Berusaha Profesor Madya Dr. Muhammad Faizal Nizamli bin Abdullah atas ucapan sebentar tadi. Seterusnya, majlis diteruskan dengan tayangan video khas yang telah disediakan oleh UPSI TV bahagian Komunikasi Korporat UPSI. Istimewa untuk yang berbahagia Profesor Teknologis Dr. Suriani binti Bakar, Timbalan Naib Chancellor Penyelidikan Inovasi UPSI. Sama-sama kita saksikan tayangan video tersebut. Dipersilakan.
Profesor Dr. Suriani Bakar dilahirkan pada 27 September 1980 di Jalan Permatang Serai, Merlimau, Melaka, Bandaraya bersejarah. Anak kepada pasangan Abu Bakar bin Leman dan Rogayah Othman, adalah anak keempat dari 5 beradik. Beliau mendapat pendidikan awal pada usia 5 tahun di Tadika Kemas, Merlimau. Sejak kecil, Suriani sering mengikuti ibu dan ayah melakukan aktiviti perniagaan dan ini mendedahkan beliau dengan kepantasan kiraan matematik, sifat kreatif dan inovatif serta kemahiran teknologi di dalam kehidupan harian. Maka, lahirlah rasa cinta kepada ilmu matematik dan sains dalam jiwa beliau. Beliau mendapat pendidikan darjah 1 hingga 6 di Sekolah Kebangsaan Merlimau 2 dan memegang pelbagai jawatan seperti penolong ketua kelas, pengawas sekolah dan penolong ketua pengawas. Beliau menjadi pelajar contoh dan kegemaran semua guru kerana sifatnya yang ramah, rajin belajar dan ringan tulang. Pada tahun 1992, beliau menjadi kebanggaan sekolah apabila mendapat kelulusan penuh 4A dalam UPSR dan ditawarkan ke sekolah idaman beliau, Sekolah Menengah Agama Syarifah Roziah Melaka. Sekolah ini menempatkan pelajar-pelajar cemerlang dari seluruh negeri Melaka. Persaingan belajar amat sengit dan mendorong Suriani untuk kekal cemerlang. Kehidupan berasrama mengajar Suriani untuk berdikari dan menjadi insan yang patuh dan berintegriti dalam kehidupan. Dengan keputusan PMR yang cemerlang, Suriani melangkah ke Sekolah Menengah Sains Muar, Johor dan berterusan mengekalkan kecemerlangan akademik. Beliau menyandang pelbagai jawatan dan terpilih mewakili pasukan negeri Johor dalam pertandingan debat sehingga mara ke pertandingan akhir forum yang berlangsung di Kota Kinabalu, Sabah. Pengalaman ini melatih Suriani menjadi seorang yang banyak membaca, kritis, pantas, tepat dan tekun dalam mencapai kejayaan. Beliau kemudiannya melanjutkan pengajian dalam bidang sarjana muda sains fizik di Universiti Teknologi Malaysia, Skudai. Ini membuka peluang untuk beliau meneroka dan mendalami minatnya dalam pelbagai ilmu fizik seperti sains bahan, mekanik, elektrik, elektronik dan lain-lain. Beliau sering mendapat anugerah dekan dan bergraduat dengan CGPA melebihi 3.50. Suriani melangkah ke peringkat sarjana di universiti yang sama di bawah program saintis cemerlang beserta program sangkutan di University of Bristol. Program mod penyelidikan ini mendedahkan Suriani kepada kaedah penyelidikan dan kerja makmal fizik dengan bimbingan oleh Profesor Dr. Samsudi Sakrani. Kursus 4 semester ini dihabiskan 3 semester di UTM dan 1 semester di University of Bristol, England. Seterusnya, Suriani mengorak langkah sebagai tutor dan menjadi pensyarah di UPSI pada tahun 2006 dengan melakukan pelbagai tugasan merangkumi pengajaran, penyelidikan, penerbitan dan lain-lain. Pada tahun 2008, beliau melanjutkan pengajian di peringkat Doktor Falsafah di Universiti Teknologi Mara dengan program sangkutan di Nagoya Institute of Technology, Japan dan didedahkan dengan ramai penyelidik hebat yang kemudiannya menjadi rakan kolaborasi. Antara penemuan hebat beliau adalah Vertically Aligned Carbon Nanotubes VACNT dari minyak kelapa sawit. Ia kemudiannya diterbitkan dalam jurnal Q1 Elsevier. Ini merupakan penemuan pertama dari Malaysia dan sekaligus membuka pelbagai peluang lain serta melonjakkan nama Suriani dalam bidang fizik nano, teknologi nano dan elektronik nano. Banyak hasil kerja beliau sewaktu PhD kemudiannya membawa kepada kejayaan dan anugerah lain kerana ia berkualiti tinggi, diiktiraf dunia serta dapat dimanfaatkan. Hasil kerja yang berkualiti memudahkan Suriani menulis jurnal, mendapatkan geran dan memenangi anugerah di peringkat kebangsaan dan antarabangsa sehingga dinobatkan sebagai penerima anugerah penyelidik cemerlang semasa Convocation PhD UiTM pada tahun 2012 serta pelbagai anugerah lain. Bidang kepakaran dan penyelidikan Profesor Dr. Suriani tertumpu kepada penghasilan bahan nano berasaskan karbon seperti graphene dan aplikasinya dalam peranti elektronik. Melalui penyelidikan yang dihasilkan, beliau menerbitkan lebih daripada 175 artikel berindeks Scopus dengan H-index Scopus melebihi 19, sitasi melebihi 1,280 dan faktor impak kumulatif bagi semua penerbitan melebihi 200. Melalui penyelidikan berasas bahan termaju dan nanoteknologi, Profesor Dr. Suriani Abu Bakar berjaya memenangi beberapa anugerah penyelidikan yang sekaligus melonjakkan nama Universiti Pendidikan Sultan Idris. Antara anugerah yang berjaya dimenangi oleh Profesor Dr. Suriani ialah Anugerah L'Oreal UNESCO for Women in Science National Fellowship 2013. Program ini adalah satu pengiktirafan dan penghargaan kepada penyelidik wanita yang cemerlang di Malaysia. Geran sebanyak RM20,000 Malaysia turut diberikan kepada beliau untuk menjalankan penyelidikan berkaitan penghasilan bahan grafin untuk dapat digunapakai dalam banyak aplikasi peranti elektronik. Beliau juga penerima anugerah Young Researcher Award in Solid State Science and Technology 2016 dari Malaysian Solid State Science and Technology Society dan mewakili Malaysia dalam The ASEAN US Science Prize for Women 2019. Lain-lain kejayaan yang beliau kecapi termasuk pingat emas dan perak dalam pertandingan penyelidikan seperti Pecipta, MTE, ITEX dan Geneva International Exhibition of Inventions. Beliau turut menerima pelbagai geran penyelidikan antarabangsa, di antaranya geran penyelidikan Tiwas Comstack Itali, Kurita Water and Environment Foundation Japan dan Malaysia Torrey Science Foundation sebagai penyelidik utama. Beliau pernah menyandang jawatan pengarah di Pejabat Karang Mengarang, Ketua Jabatan Fizik Fakulti Sains dan Matematik UPSI dan fellow penyelidik di beberapa pusat penyelidikan. Pihak universiti juga memberi kepercayaan kepada beliau sebagai Ketua Editor bagi Jurnal Educator Science, Matematik dan Teknologi UPSI. Kini, beliau berkhidmat sebagai Timbalan Naib Chancellor Penyelidikan dan Inovasi dengan agenda membawa UPSI cemerlang dan gemilang dalam 5P yang meliputi penyelidikan, penerbitan, perundingan, pengkomersialan dan penarafan. Visi akademik utama Profesor Dr. Suriani adalah pengembangan ilmu sains dan teknologi melalui penyelidikan untuk manfaat manusia sejagat. Beliau juga berhasrat agar mampu membawa nama universiti ke peringkat lebih tinggi dengan pelbagai pencapaian di peringkat kebangsaan dan antarabangsa. Profesor Dr. Suriani Abu Bakar.
Terima kasih diucapkan kepada UPSI TV bahagian komunikasi korporat UPSI atas tayangan video yang penuh bermakna sebentar tadi. Daripada video tersebut, kita boleh sama-sama melihat kesungguhan yang berbahagia Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Nab Chancellor Penyelidikan dan Inovasi UPSI di dalam memperkasakan bidang penyelidikan dan pendidikan di seluruh Malaysia. Kecemerlangan yang dikecapi beliau daripada kecil sehingga kini diharap dapat menjadi inspirasi rakan akademia dan para pelajar yang lain. Pergi ke kota, beli selasih, sayang sidara, buat halwa. Berilah kata simpulan kasih, sulamkan mesra, satukan jiwa. Seterusnya, kini tibalah waktu yang kita tunggu-tunggu. Majlis menjemput dan mempersilakan yang berbahagia Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Nab Chancellor Penyelidikan dan Inovasi UPSI untuk memberikan syarahan perdana pelantikan Profesor yang bertajuk Application of Reduced Graphene Oxide-based Nanocomposite for Solar Cell and Nanofiltration Membrane Application. Majlis dengan ini mempersilakan.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning to everyone. Thank you very much, Mr. Chairperson, Mr. Aiman and also Raziz, our smart and handsome Chairperson for today. Thank you very much. Yang saya hormati Vice Chancellor of UPSI, Profesor Datuk Dr. Amin Maktaf, Bendahari UPSI, Tuan Haji Najib Muhammad, Dean of Faculty of Science and Mathematics, Associate Professor Dr. Muhammad Faizan Nizamli Abdullah, Professor Dr. Ismail Zainul, Professor Dr. Ismail Zainul, Professor at Faculty of Science and Mathematics, Director of Research, Management and Innovation Center of UPSI, Associate Professor Dr. Nurjan Yusof, okay, Director of Strategic Department, a new department insyaAllah, Associate Professor Dr. Azmi Mohammed, Associate Professor Dr. Ahmad Jazimin Yusof, Deputy Director of Innovation, Commercialization and Consultations Unit, RMIC UPSI, respected Dean, Professor, Head of Department, and not to forget to all collaborators from national and international institutions and to all UPSI staff, students present here and via online. Okay, thank you very much. First and foremost, thank you very much for being here for my professor talk today. And the title of my presentation today is Applications of Reduced Graphene Oxide-based Nanocomposite for Solar Cell and Nanofiltration Membrane Application. So in this talk, I will explain on the application of the graphene oxide as well as in both solar cell and nanofiltration membrane application. Okay. Before I go further, allow me to give the definitions of nanotechnology. Nanotechnology, as stated there, okay, which is the fabrication and characterization and also the application of the system or material or any devices in the size of nanotechnology, in the size of nanoscale, which is within 1 to 100 nanometers. Actually, I have been working with carbon-based materials since 2005, and carbon material have a very wide application, okay, due to their unique properties, very conductive and at the same time very strong. And it also can increase the durability of the material that they will be composited with. However, the conventional carbon source to produce carbon materials are expensive and at the same time it's limited availability, okay, such as methane, acetylene, hexene, benzene, and so on and so forth. Therefore, in my initial or my previous work, we concentrate on several natural oil and also waste precursor for the production of the carbon materials. High carbon content, okay, high carbon content like waste engine oil as well as waste engine and also animal oil, okay, make it suitable as a precursor for the production of carbon-based material. For instance, waste engine oil. It can be used as a production, as a material, as a precursor for the production of carbon sphere using autoclave method, and nanocomposite structure of the carbon material with any nanostructure like metal oxide, okay, TiO2, zinc oxide, can enhance the performance of the material itself. I give you one example, like carbon nanotube, GO and zinc oxide nanocomposite. It has been reported to give a better field electron emission, the capability to emit the electron properties as compared to the pristine carbon nanotube, as well as zinc oxide and and also graphene oxide. Okay, before I go further, I would like to also explain the carbon materials. As you can see there, carbon material take numerous forms, such as amorphous carbon, graphite, diamond, fullerene, CNT, and also graphene. Okay, it's cover also activated carbon, carbon fiber. And then I give you one example here, carbon sphere, that consists of spherical shape of carbon structure with several layers. Meanwhile, carbon nanotube, made up from single or multi-layer of graphene sheet, which are rolled up into tubular structure. And the research on carbon material is more intensively studied after the discovery of spherical carbon, namely fullerene, by Kruto et al. In 1985, and the report on the CNT by the IJIMA in 1991. But actually, the research group from University of Dresden in 2006 revealed the existence of carbon nanotube in the Damascus sword, which was used by Salahuddin al-Ayyubi and his army during Crusade III in 1192. So it shows that carbon nanotube has been used, has been found long ago. And as you can see there, very strong and sharp and flexible sword. Thus, the tip can bend to the hilt. Has been used carbon nanotube itself. Okay. In terms of pricing, the price of 1 gram carbon nanotube is quite expensive. As you can see there, the price of 1 gram carbon nanotube is about RM 250, and more or less the same with the price of gold itself, which is around RM 250. In terms of application, carbon nanotube have a lot of application. One of them, it can be used as a electrode material for supercapacitor, and also a supercapacitor electrode, and also can be used in battery. At the same time, it can be used as a conductive transparent thin film and for electron emitter. And in material, it can be used as a nanofiller, as a filler to be used in nanocomposite material to reinforce resin as well as metal. In biotechnology, it can be used as a biosensor and in drug delivery system. Okay, please allow me to explain as well regarding our initial research project, where in this project, what did we do is to convert waste material into carbon structure material. As you can see there, we use waste engine oil, waste cooking palm oil, and also animal oil to produce carbon-based material. This is due to the high carbon content that within the precursor itself. Okay, at the same time, to characterize the structure and the properties of the carbon structure, and from the material, from the waste precursor, and to fabricate the nanocomposite between CNT, carbon nanotube, and zinc oxide, for instance, and to investigate field electron emission properties of the carbon nanostructure based on the waste precursor as well as its composite material. And why waste material? Okay, people will ask this question as well. And the reason why we use waste material are because they are cheap and also abundant and easily collected. And at the same time, common carbon source to produce carbon materials are expensive, like methane, acetylene, benzene, and many more. Okay, in terms of environmental reason, a quart of waste engine oil can pollute up to 250 gallons of drinking water, 40 square feet of soil, making it non-productive for farming up to 100 years. Therefore, we come up with a novel solution: waste material as carbon, waste material like waste engine oil and carbon, and from the waste cooking palm oil and animal oil can be used as a source to the for the productions of nanostructured carbon, okay, such as carbon nanotube, carbon sphere, and many more. Okay, as you can see there, waste engine oil was also underwent scientific analysis such as CHNS and CHNS and also GCMS analysis, and it shows that it has high carbon content, hydrocarbon, and also hydrocarbon chain up to 85%, 85% of the carbon as compared to the rest of the oil that being used as a carbon source for the production of carbon nanotube. At the same time, it contains heavy metal contaminant that can be used as a additional catalyst for the growth of carbon material. Okay, and then they are very economic, they are cheap, and also available at large volume. By introducing the zinc oxide, it helps, okay, it believed to reduce the first barrier, thus the electron might pass the substrate CNT junction by lower obstacle. As you can see there, the electron can easily move. While for the second configuration, okay, we put carbon nanotube CNT on the top of the CNT, and we can see that the electron have to overcome the first barrier. Okay, then the presence of zinc oxide as well between the substrate and the CNT was believed to enhance the adhesions of the nanomaterials to the substrate and release the Joule heating produced during the emission process. Therefore, it enhanced the field electron emission performance and with a stable current produced as presented in the previous slide. So now is our current research project, where in this project we concentrated on the dye-synthesized solar cell applications as well as membrane separation by using graphene oxide synthesized from electrochemical exfoliation method, as well as TiO2 that we produce using hydrothermal as well as squeegee method for the dye-synthesized solar cell application. And next is graphene oxide. So what is it and how is it created? Okay, GO in this study was carried out using electrochemical exfoliation method with customized triple tail TC14 surfactant that was produced by Dr. Azmi and the team, okay, my collaborator, and also 2 graphite rods as starting material were immersed in the water-based electrolyte at 0.1 molar and connected to the 7-volt DC power supply for 24 hours exfoliation time. And here are the advantages of having graphene oxide, which is a derivative from graphene, contain a lot of oxygen functional groups and favorable for chemical functionalizations, as well as have large surface area, and definitely it has good electrical, optical, thermal, mechanical, and electrochemical properties. As I mentioned earlier, there is a lot of synthesis method to produce graphene oxide. One of them is Hammer's method. I have to say that this is some of the drawback of Hammer's method, which is unsafe due to the utilization of hazardous chemical, time consuming due to complex step, and the powder form of GO that produce. Meanwhile, by having electrochemical exfoliation method, it offers simple, low-cost, large-scale production, less chemical use, low temperature, and the solution form of GO itself. Okay, why we need the GO in the solution form? It is much easier for the next step if you want to composite them with other polymer, for instance, and also with latex or susu getah ke, dan macam-macam lagi. Okay, then next is dye-synthesized solar cell. Okay, dye-synthesized solar cell as the third generation of solar cell was first invented in 1991 and become a promising candidate to overcome problem for the current generations of solar cell. Okay, then dye-synthesized solar cell offers simple fabrication, flexibility, and design opportunity, low-cost material, lightweight, and relatively high efficiency. This is what we are looking for. And in order to increase the performance of the SSC itself, we need to optimize several components within the SSC, which is such as counter electrode as well as photoanode. Okay, then we will use our graphene oxide that we produce in the lab to improve the counter electrode of the SSC that we will produce. As you know that the counter electrode of the dye-synthesized solar cell is a key role in dye-synthesized solar cell performance to facilitate electron transfer, which needs to regenerate and the oxidized dye after electron excitations. Okay, highly conductive material like GO, RGO, multi-wall carbon nanotube, as well as platinum. Okay, platinum is quite expensive. Okay, or its hybridizations of them has become popular choice to be used as counter electrode. Okay, in this work we use GO, RGO, and also the hybridizations of them, which consists of multi-wall carbon nanotubes, and a very thin layer of PT will be coated on top of the on the thin film, counter electrode thin film. Next is TiO2. TiO2 is the most popular semiconductor material investigated in the DSSC application, and this was due to their non-toxicity, okay, wide bandgap energy needed for light absorptions, as well as good carrier mobility. And the photoanode is also important and crucial for the improvement of dye-synthesized solar cell due to the role on providing the surface area, okay, for the absorptions of dye molecule, light absorption, and also transferring excited electron to the substrate. Okay, in this study, we will produce two types of TiO2, which is 1D array TiO2 and 0D nanoparticle TiO2 by using squeegee and hydrothermal method. And TiO2 offer better chemical and physical stability, large surface area, and demonstrate a higher DSSC efficiency as compared to zinc oxide. Thus suitable to be applied at photoanode material in this study. Okay, next is our second application of our graphene oxide as well as TiO2 in membrane separation application. Okay, this is world issue, definitely lack of clean water due to the rapid industrial factory growth caused by huge problem, such as polluted air and water, and from its waste product, which are mainly caused by the high amount of dangerous heavy metal and also dye waste that are dissolved in the water respectively. And you can see that the contaminant result from textile, dyeing industry, also pharmaceutical, metal plating, printing industry, which cause the lack of clean water, and large amount of polluted waste water is being released to the environment. Okay, then we can see that the difficulty in treating the dye with water which contain toxic substance, okay, as you can see, carcinogenic and also non-degradable substance become an important issue that needs to be solved by all the scientists. Then several methods that are generally used to remove dye from contaminated water, as can be seen there, including biological treatment, adsorption, chemical degradation, as well as electrodeposition and membrane separation. Among these methods, membrane filtrations gain considerable interest due to its several advantages. As you can see there, simple operation, low energy consumption, and no phase changes, as well as easy automation, low pollution, and high recovery rate. And in terms of polymer that we will use in this study, in our research, is that either PVDF and also PES. Okay, PVDF demonstrate excellent properties, including including good mechanical properties or strength and chemical resistance, good thermal stability, hydrophilic in nature, thereby making it applicable for water treatment application. But some modification needs to be done into the polymer, as can be seen there, either through grinding or polishing or surface coating, blending with organic or inorganic material, plasma treatment, and additive with through nanomaterial like GO, RGO, silica, zinc oxide, TiO2, aluminium oxide, as well as ferrum oxide. Okay, as well as additive from polymer itself like PMMA, PVP, as well as PVA. And for your information, graphene oxide, okay, was utilized as an additive to fabricate the hydrophilic membrane. Okay, this is the advantage of using graphene oxide, which it offers advantage for the water treatment, okay, due to its large surface area, calculated up to 2,000 plus meter square per gram, good chemical stability, high mechanical strength, Young modulus is quite high, and at the same time as exfoliated GO thin film, okay, GO that we produce using electrochemical exfoliation method has a lot of oxygen functional groups such as carboxyl, carbonyl, epoxyl, hydroxyl group. GO is highly hydrophilic. Okay, at the same time, TiO2, okay, is also an effective candidate to reinforce PVDF polymer materials due to its hydrophilicity, chemical stability, low toxicity, and commercially available. TiO2 is considered among the best metal oxide to overcome the fouling issue by increasing the membrane hydrophilicity, and in addition, it also possesses a small particle and large surface area. Okay, therefore, in this study, we will combine PVDF with graphene oxide that we produce in our lab, as well as TiO2 that we produce in our lab for the membrane separation application for dye rejection. And here are the objectives of this project, where we have to produce, we will produce the GO and RGO-based thin film and its hybridization with platinum, okay, and also multi-wall carbon nanotubes for dye-synthesized solar cell applications, as well as to synthesize various kind of TiO2 nanostructure and its hybridization as photoanode thin film for dye-synthesized solar cell application. And then from both counter electrode as well as photoanode, we will fabricate. Okay, we fabricated dye-synthesized solar cell by using various kind of TiO2 nanostructure and photoanode, and as well as counter electrode thin film. And to fabricate nanofiltration membrane by utilizing the synthesized GO for dye rejection application. And here are the methodology that we use in this study, okay, where we have to produce graphene oxide, and then we need to reduce them. We reduce the oxygen content within it, and also its hybridization. Okay, RGO was produced using electrochemical exfoliation method using SDS and TC14 surfactant, and the utilizations of surfactant is to ensure the intercalation, dispersion, and stabilizations of the graphene oxide layer during and after the synthesis process using electrochemical exfoliation method at 0.1 molar, 7 volt, and 24 hours synthesis time. And after that, the sample need to undergo reduction process using chemical reduction process utilizing hydrazine hydrate. Then why we use hydrazine hydrate is due to its effectiveness for reducing the oxygen content and producing thin film. And next is hybridization process, hybridizing the graphene oxide that we produce using with multi-wall carbon nanotube in order to increase its conductivity. That will also help to increase the performance of the dye-synthesized solar cell that we produce in our lab. Okay, in terms of counter-electrode thin film fabrication, you can see that we produce counter-electrode thin film by using spraying deposition method. Okay, and this is the method that we use and available at our lab, and put PT coating by sputtering. And there are a few samples and different type of counter-electrode that we produce. And in terms, meanwhile, for photoanode film fabrication, we use hydrothermal growth method to produce TiO2 nanostructure with different structure. And you can see that we use titanium butoxide, and we put in the autoclave, okay, the FTO substrate with conductive surface facing outward within the hydrothermal solution that we produce. And for the squeezy method, okay, we produce TiO2 paste preparation, and then we put on top of the TiO2 nanowires, nano rod, or whatever structure that we produce from hydrothermal growth method on top of the FTO. Then we will use TiO2 paste that we produce and by using squeegee method. And here are the parameters that we optimize definitely. Okay, next is dye-synthesized solar cell fabrication. This is the structure of the dye-synthesized solar cell fabrication. As you can see that there is a TiO2 nanostructure where we make them as a photoanode, and graphene oxide based counter-electrode thin film. We vary both of them, and we fix dye in the and also the electrolyte that we use within the sample. Okay, the TiO2 photoanode was initially immersed in 0.3 millimolar and 7-1 dye for 24 hours, and the dye need to be prepared based on 1-to-1 ratio between the acetonitrile and also butanol. Okay. Okay, next is the preparations of nanofiltration membrane fabrication. Okay, the method that we use is phase inversion method, where we mix the polymer, which is PVDF, with the GO as well as the TiO2, and they will undergo removing the bubble process and casting, as well as coagulations process. Okay. Next is results and discussion. Okay, for your information, in terms of result and discussion, I would like to explain as well. We analyze both the counter-electrode that we produce using GO that we produce in our lab through electrochemical exfoliation method, and then the photoanode from the photoanode by using TiO2 with different structure. And we study thoroughly the morphology, the structure, the structural. Okay, like this one, you can see that this is RGO-based thin film, okay, that we produce. Then we can see that the RGO, okay, demonstrate the thinnest layer of 2 to 4 layer with the transparent crumpled tissue-like morphology and the fold-up layer in the edge plane. And at the same time, for the hybrid counter-electrode thin film, we hybrid them with PT, very thin layer of PT, because we know that PT is quite expensive, as well as with the multi-wall carbon nanotube, the carbon nanotube that we produce on our own in the lab. You can see that the film shows the TC14 GO, PT, and multi-wall carbon nanotubes. Okay, then we the summary of measured ID-ID ratio, the transmittance, as well as optical band gap and the resistivity, the structural, optical, and electrical properties of fabricated counter-electrode thin film are tabulated in the presented table. Okay, from that, I would like to highlight the optical band gap that we calculate by using dot plot. Okay, then the lowest EG value is about 3.97, it's quite high, and it is suggested Okay, the film that suggests that the film has the fastest electron transport, and then rendering its effectiveness for the application for the counter-electrode film application. And at the same time, due to the existence of PT and also carbon nanotube, add to the overall conductivity of the counter-electrode film and thus decrease the optical band gap of the produced graphene oxide-based counter-electrode. Meanwhile, for photoanode, as you can see there, this is the fabricated photoanode using various nanostructure TiO2, and the cross-section FSM image well analyzed, because this will determine the significant effect toward improving the electron transport to produce high efficiency dye-synthesized solar cell that we produce. And from this analysis, we can see, okay, this is among the, this is by using TiO2 nanoparticle, TiO2 nanorod, nanoflower with TiO2 nanoparticle, and also TiO2 nanotree, okay, nanowires, and many more. Here is the TiO2 with nanorod and nanocauliflower, because the shape is more or less like cauliflower, so we name it TiO2 nanorod with nanocauliflower. And the structural and optical properties of fabricated photoanode film, we investigate its crystallinity percentage as well as transmittance and optical band gap. So based on those studies, you can see that the lowest EG value is around 2.89 and suggests that this film has the fastest electron transport, and then is quite effective for the application for photoanode film to improve the dye synthesized solar cell performance. Okay, next, dye synthesized performance. Okay, based on the solar simulations measurement, the highest you can see that, okay, this is the analysis based on the optimization done toward the counter electrode as well as toward the photoanode that we produce in the lab. So here we can see that the first one is the utilization of various counter electrode thin film, and then the optimization done toward the utilizations of different kind of photoanode film, effect of different hydrothermal synthesis time, and also annealing treatment that we need, that we supply for them, and at the same time effect of the hybrid photoanode film and its configuration, and effect of other variety of TiO2 nanostructured thin film for the productions of photoanode film. Okay, among all, the best, okay, based on the solar simulator measurement, the highest dye synthesized solar cell efficiency was achieved by using TiO2 with nanorod and also nanoflower with graphene oxide and nanoparticle as a photoanode, okay, which is around 1.559 efficiency, and with high VOC and JSC and FF value of 0.74 volt and 3.275 milliampere per cm square and 53.5 respectively. And this was due to the incorporations of TC14 RGO, which enhanced the electron transport and thus decreased the electron recombination. In addition, the thick TiO2 nanoparticle layer on top of that and the vertical align of TiO2 nanorod layer provide a large surface area for dye absorptions and direct electron pathway respectively. And this is also supported by utilizing high conductive counter electrode film that consists of RGO, multi-wall carbon nanotubes, as well as a very thin layer of PT, okay, that also provide, enhance the electron mobility within the SSC structure. Then this result shows that the annealing treatment for hydrothermal growth significantly enhance the DSSC, the dye-synthesized solar cell performance. Okay, at the same time, we also investigate the efficiency of each single material that we produce, like the utilization of various counter-electrode thin film and the effect of different hydrothermal synthesis time of the photoanode itself, where it produces TiO2 nanorod, nanoflower, and TiO2 nanoparticle via squeegee method. We can see that the efficiency of the film that we fix the counter electrode, we can see that the efficiency of the film is not as high as the previous sample that we produced just now, that we presented just now. And the same goes for the effect of post annealing treatments of photoanode film, which is, this one is TiO2 nanorod, nanoflower, TiO2 nanoparticle. Okay, by using the same counter electrode, we can see that the efficiency is around 1.4, while for the last one, the effect of other variety of TiO2 nanostructure by using TiO2 nano wires, okay, nanowires and TiO2 nanoparticle, the efficiency increased, but not as high as the one that we used previously, okay, by using fixed CE film, which is TC14, RGO, multi-wall CNT, and also PT coating on top of it. Okay, our next application is on the nanofiltration membrane that we produce using PVDF with TiO2 as well as graphene oxide. And these are the morphology properties of the nanofiltration membrane that we produce. So you can see that the second structure, okay, which is the PVDF TC14GO TiO2 nanofiltration membrane, display a thin and dense skin layer with well-developed of wider and longer macrovoid structure surrounded by sponge-like layer compared to the PVDF with AOT4GO TiO2 film. Okay, membranes. So this might due to the higher GO within the sample. And as you know that it is very important to get this is very important in order to get an excellent water permeability in the sample, and high amount of GO noticeably influence the pore structure of the sample that we produce. Okay, and then the abundance of hydrophilic group of GO, oxygen functional groups, okay, increase the membrane hydrophilicity, thus accelerate the water diffusions during the exchange of non-solvent and solvent, and led to the formations of large macrovoid structure. Okay, we also did ID-ID ratio, we also did membrane Raman analysis toward the sample, and we can then the ratio can be used to investigate the defect level within the sample, and based on the calculation, we can see that the second sample have higher ID-ID ratio or higher defect level. So these result confirm that higher interactions and better GO dispersion within the sample that we produce. And okay, for the contact angle and porosity of the sample, because we need the sample to need to have low contact angle, and you can see that the sample with low contact angle is the one that we produce using TC14 GO-TiO2 PVDF, and the contact angle measurement was used to investigate the membrane surface hydrophilicity, and we can see that the lower contact angle of second sample indicates that membrane hydrophilicity improve as the amount of GO content in the PVDF TC14 GO-TiO2 membrane increase. And this was believed due to the utilizations of triple-tail TC14, which provide an extra change for GO and PVDF polymer interconnection. In addition, abundance of number of oxygen, oxygen containing functional group within the graphene oxide that we produce resulted in a high water molecule diffusions rate through the membrane that caused by the hydrogen bond. As a result, membrane become more hydrophilic and owned lower contact angle. This is what we aim for, and the result is actually in good agreement with the FSM analysis that we did previously, which show bigger pore size than PVDF AOT for GO-TiO2. And higher GO amount within the second sample lead to the higher porosity and bigger pore size, which increase the mass transfer rate between the solvent and non-solvent during phase inversions. And in addition, high membrane hydrophilicity was also increased, as the contact angle decreased. Next you can see that the water flux and permeability, and the second sample that we produced with high quality GO, it presented 3 times higher water permeability as compared to the first sample. And in terms of dye flux as well, it also has higher flux, higher dye flux as compared to the first sample. And in terms of FRR value, we can see that it indicates high, FRR value is higher, indicate good anti-fouling performance. As a conclusion, we can say that here are the optimum parameter that we need to optimize, as well as to improve, to give the better performance of dye-synthesized solar cell in terms of its how to improve the counter electrode, as well as photoanode and the hybridization of the photoanode thin film. Meanwhile, for the membrane application, and the best membrane application, or the optimum one, with the PVDF TC14 GO and also TiO2, where it has highest water flux, water permeability, highest hydrophilicity, as well as dye flux. I would like to take this opportunity as well to thank to all my students, my master and my PhD student presented here today are Dr. Mokayana via online, and also Norma Nisa, my PhD student. And I would like to share as well the achievement all made by all my students. Most of them graduate on time and with special award during convocation, and they publish a lot in Q1 and Q2 high impact journal, and won many award during research exhibition. This is among the achievement of the student. And they won Anugerah Bitara, Sempena Istiadat Convocation, and also there are also attachment program at Nagoya Institute of Technology, Japan, and they won Anugerah Icon Varsity Berita Harian, dan juga 3-minute thesis, third prize for 3-minute thesis. And at the same time, this is among the award by my student, Bitara Award, UPSI, Silver Medal, and Best Oral Presentation. And one of them is now working at Department of Physics USM, Dr. Noafiza Maeser. And for Dr. Mokayana, dekat situ dia ada tulis, pelajar cemerlang, hasil didikan pensyarah yang cemerlang. Tapi bagi saya, pensyarah cemerlang kerana pelajar-pelajar ni yang cemerlang. Dan Dan ini antara pelajar-pelajar saya, and this is my international student. They won a lot of international and also award during convocation, which is Bitara Award, International Student Excellent Award, and Best Poster Presenter, and third prize winner for the 3-minute thesis competition UPSI, and UPSI representative on the national 3-minute thesis competition at UTP. And now Dr. Mokayana is now a researcher at Badan Research and Innovations National Indonesia, and many more. Then I would like to thank Nanotechnology Research Center and the Faculty of Science and Mathematics, okay, for their great achievement and support and all the facilities. And this is among the activity with the student. And my sincere thanks goes to all the my great and also supportive collaborators from national and international counterpart. Okay, Dr. Associate Professor Dr. Azmi, Dr. Saufi, and last but not least, my beloved husband and children that are present today. Okay. Okay, to me, I'm not what I am today without the great support from all of you. Thank you very much. Thank you for your attention.
Terima kasih diucapkan kepada yang berbahagia, Profesor Teknologis Dr. Suriani binti Abu Bakar, Timbalan Naib Chancellor Pendidikan dan Inovasi UPSI atas syarahan yang telah disampaikan tadi. Seterusnya, dijemput semua para tetamu untuk mengambil gambar sebagai kenang-kenangan bersama div-div kehormat kita pada pagi ini.
Tercipta sebuah sejarah, kehebatan gedung, ilmu yang indah, sehingga melonjak tamadun dunia menjadi lanskap yang sempurna.
Disinilah bermula segalanya, sebuah titian pendidikan, menggenggam budi yang penuh arti. Dari SITC ke UPSI,
salam seabad suluh budiman, mendidik anak-anak bangsa dengan ilmu di dada. Salam seabad suluh budiman, namamu jadi sebutan dunia. Telah tercipta sebuah sejarah, kehebatan gedung, ilmu yang indah, sehingga melonjak tamadun dunia menjadi lanskap yang sempurna. Pasti harum mewangi ibu tercinta, berseri bersinar. selamanya.
Dengan berakhirnya sesi fotografi sebentar tadi, maka berakhirlah program kita pada pagi ini. Terima kasih buat semua hadirin yang hadir bagi memeriahkan majlis kita pada pagi ini. Kami, ahli jawatan kuasa program, mohon maaf dan ampun sekiranya terdapat salah silap semasa mengendalikan majlis. Mengumumkan perarakan keluar div-div jemputan dari perkarangan majlis. Dijemput semua hadirin untuk mengambil pek makanan yang telah disediakan di pintu utama Dewan Konvensyen e-learning. Sekian, wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.